Do all civilizations in the universe face similar problems at our stage of development? To some extent, we can say yes. If there are civilizations out there living on planets, then they very likely understand the threat of asteroid impacts. Other bullets they may dodge. Say they never developed nuclear bombs as weapons because their social conditions did not include warfare. We simply can't know until we see them. But one thing that they may well face is at least a period of climate change as their species develops technology. Industrializing a world to build a civilization will produce byproducts. Eventually, though, climate change probably evolves into the act of terraforming worlds, where it becomes a tool rather than a problem. This assumes, of course, that civilizations generally survive this stage of development. They may not, and we may not. But it's also worth noting that we're still here, and we do stand a good chance of still being here centuries from now. But does that make us a success as a civilization? Are we somehow above the galactic norm, and that one possible solution to the Fermi Paradox is that civilizations almost invariably destroy themselves, which is why we don't see evidence of them? Whether that's the case, we may never know. While SETI searches for exocivilizations in a number of different ways, they haven't found anything yet. While that could easily be due to the fact that we've barely scratched the surface as far as searching goes, what happens if centuries from now we still see only silence?
Joining John today is Dr. Adam Frank, a professor of astrophysics at the University of Rochester in New York. He studies the processes that shape the formation and death of stars. Adam is a theoretical computational astrophysicist and heads a research group that is developing new tools for simulating the cosmos. A self-described evangelist of science, he is the co-founder of National Public Radio's 13.7 Cosmos and Culture blog, as well as a regular on-air commentator for All Things Considered. Adam is the author of 3 books. His most recent book, Light of the Stars, Alien Worlds and the Fate of the Earth, is an exploration of the astrobiological nature of our universe.
Adam Frank, welcome to the program.
It's a great pleasure.
Now, you have a book out, Light of the Stars, Alien Worlds, and the Fate of Earth. What was your thinking behind the title?
Well, titles are always very difficult with a book because, you're kind of you want a little bit of lyricism, but you also want people to understand what it's about. The idea here is that one can think of what is our fate, especially when it comes to climate change and the changes that are happening that we're driving as a civilization in light of the stars? Meaning when we consider our problem as an astrobiological problem, a problem that perhaps is generic to any civilization that arises on any planet, then the premise is that you actually get a very different way of thinking about about civilizations and their fate on their planets, and particularly ours as well. So it was really the sense, in light of the stars, in light of the possibility of all the planets and all the possibilities for civilizations and their trajectories, how does that change how we think about what we're doing with the planet now?
Now, you begin in your book, you have an interesting idea. You cast human civilization as a project, this project of civilization that has begun since the end of the last ice age, or what you call the Anthropocene. Is that really, if we apply that and say that, alien civilizations run a parallel course to ours, even though we've never seen one, we do have a sampling of one ourselves. Do you think that our project of civilization so far can be called a success?
Well, yes, absolutely. It depends on what you mean by success. I mean, if we look at the blue-green algae that changed the atmospheric composition and gave us the oxygen in our atmosphere 2.5 billion years ago, were they a success? Absolutely. They were, as a species or as a particular kind of organism, they spread across the planet. Their metabolic activity was so voracious and so prevalent that they literally changed the atmosphere, the chemical constitution of an atmosphere for an entire world. That's pretty remarkable. In the end, it didn't work out so well for them because by driving the oxygenation of the atmosphere, they ended up, since they couldn't breathe oxygen or exist in oxygen environments, they were left to non-oxygenated warrens like the insides of our stomachs or other places that don't have oxygen. But in terms of a success, I think in many ways that what climate change shows us, driving climate change shows us, is our success as a species. We have our powers. In this case, we have self-consciousness. We're able to decide the projects we take on. And this project of civilization has been an enormous success in terms of spreading across the planet, our numbers growing, our capacities growing, and our capacities growing to the point where, we were able to change the atmosphere of an entire planet, which, as I like to say, is not bad for a bunch of hairless monkeys.
True, but a blue-green algae also did that with the oxygenation event, profoundly changed the atmosphere, perhaps in a way that could be visible from a distance. If you're some alien civilization looking at exoplanets and you see that strange oxygen mixed with a little bit of methane, certainly starts looking like there might be a biosphere there. And even though you probably couldn't tell if there was a civilization, you could tell there's something going on.
Right.
Do you anticipate that that's going to be one of the ways, our chief way of finding life in the universe will be looking for these types of gases in planetary atmospheres?
You mean biosignatures?
Yes,
like biosignatures. Yes.
Uh-huh.
Yeah, I think that's actually, as I like to point out to everybody, we are undergoing a profound revolution in SETI, which, beforehand was, let's go take some radio telescopes and point them at stars and hope that someone's beaming a message at us, a high wattage message at us. And now, because of the exoplanet revolution, and we have all of these planets that we're going to be staring at anyway, that we can stare at via transits, we can do the atmosphere characterization, and that there's signatures. There's going to be, really important signatures in that atmosphere about all the processes that have happened on the planet, including the possibilities of life and perhaps the possibilities for civilization.
So regarding civilization, now that begins to introduce things like technosignatures, where, say, you look at a planetary atmosphere and you see CFCs or something like that. Right. Is there, that I guess would be a dead ringer for a civilization, but are there others? Other gases that
there are a number of others, that might, both. But it's not only gases, though. There's also, for technosignatures, there's other things you can look at as well. I am going to a conference in 2 weeks that is a NASA workshop. And it's the first, if I'm correct, and I'm pretty sure I am, this is the first time NASA has been willing to host a conference or a workshop on intelligence in the universe, I think since the late 70s, maybe early 80s. For the last almost 40 years, NASA has just, because it got burned a couple times in Congress about SETI, has just not wanted to deal with intelligence. And so, they had their entire astrobiology program stopped dead at intelligence. Like, you were not allowed to talk about it, you were not allowed to propose anything about it. And now it's remarkable that there's actually some, interest. So they're holding a workshop to ask astronomers to come up with ideas for technosignatures. So one example of a non-atmospheric, or something that's not in the atmosphere but still might be able to be seen, was a proposal by Lingham and Loeb that if the civilization covers its planet or covers a fraction of its planet in solar panels, that there would be a spectral edge, a reflectance edge that would show up because of all the silicon. Just like planets with vegetation would likely have a red edge, or at least have a, if it's chlorophyll that's driving it. So there's a number of different possibilities. Even the possibility of seeing night illumination, artificial illumination at night.
Now, you mentioned the vegetative red edge. Now, that's due to essentially photosynthesizing cellular plants become reflective at a certain point in the infrared spectrum, right?
Right.
Do you think that now, Would that be the easiest one to look for, maybe, because it would be so distinctive?
That among the biosignatures, I mean, I've seen a lot of discussion about the red edge, and I've even seen papers that calculate what that edge would look like for different kinds of alternative photosynthesis. So, for example, if you have a planet orbiting an M dwarf, which is much cooler and therefore has a very different spectrum that doesn't peak in the in the yellow as the sun does, then you'd have a different kind. Evolution would probably choose to make photosynthesis tuned to different longer wavelengths. So I've even seen that. So I think that is a very promising kind of biosignature.
So now that brings up an interesting idea. Came from another paper. I forget who wrote it. That they suggested that if you did have like analogs of Earth plants or on a planet around a red dwarf, they wouldn't be green. Probably they would be sort of black and different, much better suited to absorb redder light.
Right.
Now, back to climate change for a moment. Now, climate change as it stands right now is a bad thing. If anthropocentric climate change is, but it can also be a good thing if you want to do things like terraform planets. Now, if you had an alien civilization that was terraforming a planet, say something similar to Mars, where it shouldn't have as much carbon dioxide as it does, it should have lost it perhaps. Is that a viable technosignature?
Well, people have talked about this, and actually people have even talked, there's even a few papers out, again, whose names I can't remember, who have actually looked at just could you look for greenhouse warming above, it wouldn't even have to be as dramatic as actual terraforming, but of just, industrial produced greenhouse warming. So that has been a discussion in the literature. And I think, the jury is out, but this is such a new field for us to start thinking about how, and that's why what is part of the thing I was trying to say in the book is this understanding, the whole reason why you want to start looking at climate change. And as you said, it could be a bad thing. If you're a civilization and you are born in a certain kind of climate state, and then you trigger climate change, which I'm arguing in the book is actually going to be pretty generic. You're going to have a hard time not triggering climate change. Climate change in general, if it takes you out of the climate state that you were born in as a project of civilization, it's bad because you may not make it through because of that. So, the seeing climate change in this way as sort of understanding it as something that civilizations will trigger whether they want to or not. And then the question is whether or not they make it through. It really does change how we understand our own climate change, right? Because so much with climate change now, there's all this politics that's involved in it. And it just gets caught in this, the way we talk about it is so tribalized. That we're missing the real point and its real importance. We think it's a Democrat versus Republican issue or a conservative versus environmentalist issue, and we're really missing the point about what climate change means for any civilization, and in particular ours, because we're the one, this is the one that we care about. So, sort of casting it in this light, right, is the different questions you're asking about good or bad, or, what would it mean for a civilization to use climate change or CO2 production, I think really changes how we should understand our own predicament right now.
In other words, a dangerous politicization of science gets in the way of the actual science. But we have... we have examples within planetary science of this sort of thing, looking at both Venus and Mars, which are both thought to have once been water worlds like Earth, at least briefly, and now they are not. They're very different, especially Venus.
Well, that's exactly it, is that, as you said, it's the politicization gets in the way of the actual science itself. And what people, I think, really don't understand or, fail to sort of include in their discussions of climate change as a general, phenomena for us as a civilization, is that we understand climate change so well, in part because we have lots of planets to see climate change happening on. We think of ourselves as being unique, when in fact, on many levels, we're not. So as you said, Venus was a world that, at some point may have had an ocean. So there's just a couple of papers. David Grinspoon and colleagues published a paper that said, it could have been that a few 100 million years ago, Venus hosted an ocean, and then a runaway greenhouse effect was triggered on Venus because it eventually lost its water molecules to space. And so that was a profound example of climate change. On Mars, we know that Mars once had water on it for sure now, early in its history, and it also lost its water and has undergone climate change. And with Mars in particular, we understand the climate so well that we can make models of it. We have very detailed computer models, the same kind of models we run for climate change on Earth, that can predict the weather, on Mars, quite accurately. So people really don't understand that the science of planets has come so far because we have lots of planets to understand. We've been sending our robot probes to all these planets for decades now, and they've taught us really how to think like a planet.
Speaking of this planet, Earth, you mention in the book, in fact, I think it's a chapter, you say masks of Earth, how Earth has looked different over its 4.5 billion year history. And in fact, at one point, it appears to have almost frozen over and went into this cycle of snowball Earth, and then a little bit of a thaw as more greenhouse gases were emitted into the atmosphere, which warmed it a little bit. Then it went back and forth. Or you could take climate mass extinctions like the Siberian traps, where volcanism dramatically changed the climate and caused a veritable mass extinction. So we are not the worst that this planet has seen as far as climate change. But one of the problems is that there are things we don't understand because the Earth's atmosphere is very dynamic and we don't really know what we could do to artificially mitigate climate change. If we make it that far to where we get enough of a handle on it to essentially terraform Earth back to its original or ideal state, do you see that in our future? Do you think eventually we would be able to command the atmosphere?
Well, actually, you introduced a bunch of really interesting ideas there. Lisa, let's first start about the idea of the ideal state, right? So there is no ideal state, right, except for us. So our project of civilization began after the end of the last ice age, which is the beginning of the geologic epoch we call the Holocene. So for the last 10,000 years, the Earth has been in the Holocene, which is a period of relatively moist, relatively warm conditions. And all of human history, from the beginning of agriculture to the creation of cities, to the expansion of international trade, which first was, around the Mediterranean or the South China Sea, to then actually being, going across, from Rome all the way over to China. That entire project took place within a particular climate state, which we are now pushing the Earth out of. But I think the important thing for me when we think about the Anthropocene is that there's no going back, right? There's the idea that you can somehow have, zero impact. So, I'm a big backpacker, and there's that whole idea of, leave no trace, which I believe in strongly. But the idea that you could leave no trace, that as a civilization we could leave no trace on the planet, I think is impossible. It's a fiction. When a civilization, any civilization, us or one that grows on another planet, gets to this level of energy harvesting, there's just no way not to have an impact on the coupled planetary systems. So, there's no going back. There's always going to be an impact. And now the question is, how do we create an impact that doesn't put us out of business? It doesn't put the civilization out of business. So, you're asking kind of about geo-engineering in some sense. Would we do large-scale terraforming? And I think depends on what you mean by that. I mean, especially right now, we just do not understand enough about how climate works to be able to throw that kind of monkey wrench into the system, right? In some sense, climate change, based on fossil fuel use, is an unintended consequence of deploying a certain kind of energy harvesting method. And so doing anything else along those lines, like sunshades or, putting iron particles into the ocean to stimulate phytoplankton growth, I think is just, the unintended consequences are just too dramatic that you do not want to mess with that. When the simplest thing you could do is just stop using fossil fuels. Right? Why push yourself into some kind of super dangerous, liminal kind of technology when just stop using fossil fuels and switch to another energy harvesting modality? So maybe sometime in the distant future, we could imagine having that kind of control over climate. But I think we are so far from that that's not what we want to be thinking about now.
Better to think about fusion and anything that we can get that doesn't use fossil fuels. Though that does beg a question. If let's say the solution to the Fermi Paradox is that life is just rare, that wouldn't that make plant-based crude oil the rarest substance in the universe?
Well, I don't, so let's talk about the Fermi Paradox for a minute. So the Fermi Paradox, there's really two ways to think about the Fermi Paradox. And sometimes when people say Fermi Paradox, they mean one or the other thing. So the Fermi Paradox, if we're talking about the Fermi Paradox, meaning that, we have looked for life in the universe and we haven't found any, therefore the stars are silent, which is a beautiful image that David Brin came up with. But in terms of whether or not the stars are silent, we cannot say that yet, right? People sometimes have this idea that, scientists, astronomers are out there doing SETI searches every day, and we've looked everywhere and we haven't found anything. And nothing could be further from the truth, right? As we were talking about before with NASA has never funded anything near a complete SETI search. NASA's really never funded any real SETI searches. So what has been done has basically been little dribs and drabs by people when they could get telescope time. So as Jill Tarter pointed out, if the stars are the ocean and we're looking for life in the ocean, what we have looked at so far is a thimble, right? And you don't want to look at a thimble full of water and go, oh, there's no life in there, therefore the whole ocean is lifeless, right? So, we are a long way from being able to say the stars are silent. So in that sense, there is no Fermi Paradox, right? Now, what Fermi, in some sense, was thinking about, and really what Hart in I think it was 71 or 79 in his famous paper, was talking about was why haven't we been visited, right? The calculation he did was to look at if you had a single civilization that started sending out, colony ships at even a tenth of the speed of light, what you find is that they would sweep through the galaxy on the order of 600 or 700,000 years, which is pretty short compared to galactic, the age of the galaxy. So in that sense, why aren't there aliens here now? That's a harder part of the Fermi Paradox to deal with. And actually, we have a paper that we're just sort of putting together on that. And I agree, that is actually hard because we actually looked at in the paper was, well, it's not so important that they're here now. What if they visited 1 billion years ago, right? Because we wouldn't even know whether we'd have no evidence. If they visited 1 billion years ago and had a civilization for 1 million years, there might not be any fossil record or any record of that. It's pretty hard to preserve something like that in the fossil record.
Right.
But we still found.
There's a temporal aspect to this as well as a physical aspect. Now, we'll get deeper into this when we come back. I have to take a break. So joining me today is Dr. Adam Frank, and we're talking about SETI, the Fermi Paradox, and Dr. Frank's new book, Light of the Stars, Alien Worlds and the Fate of Earth.
And now, a message from our sponsors.
You have no new messages.
Oh dear. To sponsor Event Horizon, get in touch with our producer. Details at the website. Are you looking for a subscription to fill your notification tray? Perhaps Event Horizon is for you. It's totally free and we upload a new video every Thursday.
I am back with Dr. Adam Frank today here on Event Horizon. Dr. Frank, we were talking about the Fermi Paradox before the break, and there's a lot more to that than simply asking, why don't we see them, when we ostensibly should see them. Is it possible that they're just very hard to see and that maybe Nikolai Kardashev hadn't quite nailed it and that civilizations don't create these huge galaxy-spanning empires. Instead, they may be more pragmatic and go on a smaller scale, perhaps or initially as a result of climate change to save their own planet, and that they're smaller and more discreet, and we just don't have the power to see them yet. You think that's likely?
Well, I think it's possible. I mean, the problem with anything when we think about exocivilizations, right? It's time to put the word aliens to rest because it's been co-opted by too many people for weirder things like ancient aliens. So when we think about exocivilizations, the problem is we're so unconstrained by scientific principles that, it becomes we're basically writing science fiction stories, right? Which is awesome, but that's not very helpful often in trying to nail down what has happened, which is why, in my book, what I'm saying is, the one thing that science will allow us to say about exocivilizations is they probably trigger climate change, right? Because and we can get into that later, but that's sort of something that you can, you can use very generic principles to say, if you're a civilization, you probably triggered climate change. But to your point, there's so many different ways in which the question of the visibility of exocivilizations, there's so many different possible answers to that. So one is, right, that they're not beaming signals at anybody, right? They don't have these high-powered, transmitters beaming signals saying, hey, we're here. And they could do that for a bunch of reasons, like they're just not interested. Or B, right, the idea of the wolves between the stars. You just don't want to communicate your existence. You don't know what's out there, right? It could be predators, so to speak. So, I think that's a very strong argument. You don't want to necessarily announce your presence. But then also, they just may be using technology. The period during which they're using radio, for example, may be very brief. And then it goes on to lasers, tight beam communications, in which case, that's what you should be looking for. Or the best way to detect them is going to be, you need super sensitive instrumentation to be able to detect their rocket motors or the lasers that they use for propulsion. So I think there's a lot of different possibilities for how exocivilizations configure themselves, such that the question of their detectabilities becomes quite myriad.
Now, I guess you could ask the reverse question, too, is how visible are we? If we have a civilization within 100 light years that has a chance of picking anything up from Earth and knowing we're here, and thus knowing that we could be contacted, do you think our emissions are just too weak? Do you think that, say 10 light years out, you would just need equipment that's probably impossible to build, a radio telescope the size of Chicago or something? How visible are we?
We're definitely detectable, but you'd have to look right at us, right? That's the thing. So, when Frank Drake's project Ozma, that is the first SETI search ever, he did a calculation, he when he was setting that up, he calculated how far our radio emissions would be detectable. And that's how he came to the conclusion, like, oh, wow, within 10 light years, I really could. Somebody could see us, so let me look out to 10 light years and see, what I can find. But again, you'd have to look exactly at us. You'd have to be looking for something with a pretty large detector. So we certainly are visible, but we're not wildly visible. So if you're looking, imagine that life is not hyper common or intelligent life. So maybe it's only 1 out of, 10 million stars. Then that means you're going to have to search through a lot of stars before you find a civilization that is emitting by mistake signals. And so, that's a large search strategy that you have to go, because you also have to know what you're looking at. Should you be looking in radio? Should you be looking at which radio frequencies should you be looking at? So, that's the thing. The parameter space for traditional SETI is, in terms of, I'm going to look for radio signals, it's a very big parameter space. And that's why, again, it's far too early to ever say that we've looked and we haven't found anything.
Now, it's always been the case where, with radio SETI, they look at things like the hydrogen line, 1420 megahertz.
Right.
And that's under the assumption that alien scientists, should they want to be visible, would make themselves visible in a way that scientists across the galaxy would recognize. But that's not the only way to do it. Might it make more sense? Do you remember the paper years ago, I think it was by Luke Arnold, where he suggested visible light louvers and things that would pass in front of stars so that photometers, And then, of course, that led to that odd case of KSE 8462852, which, granted, that was never very likely to be an alien construct, rather just some, megastructure. Mega dust is what it probably really is. But this idea of just simple visual communications like that, just putting a louver up or a strange shape made out of mylar, do you think it's got to be a lot more viable than a giant, multiple terawatt beacon, omnidirectionally, omnidirectionally screaming to the... So what do you think? Do you think as we go further, we might see something like that, whether it's there intentionally or not? Do you think that's actually a viable technosignature, as sort of out there as it is, that, mega structures, could be lurking out there?
Well, I think we have to be prepared for it. This is the cool thing about where we are right now, right? For the next 100 years, we are going to be staring at planets with exquisite resolution, right? And we're going to get ever better resolution at the amazing thing about the last 20 years is that we went from not knowing whether there were any planets anywhere in the universe except our solar system to now knowing that there are planets everywhere, that every star pretty much in the sky has a family of planets orbiting it. And, we are now gone from that conclusion to actually building a census of these planets. And then from there, we're actually getting to the point where we can characterize the atmospheres of these planets. So the next 100 years, the most exciting fields, at least as I would think, in astronomy is going to be like really coming to understand everything we possibly can about these planets, which means staring at them. And who knows what we're going to find. I mean, I thought the whole thing about the alien megastructures was awesome. Not because I ever thought that it was going to be an alien megastructure, but the fact it was an exemplar. It was this planet that we had found or this system that had the most bizarre behavior that we did not expect at all. And what it really showed was you can't be so biased that you're like, it can never be an exocivilization, right? No matter what, it can never be an exocivilization. That's crazy, right? Why would you say that? So we actually, just like we need to be prepared for possibility of finding chemical markers of a biosphere, of an exobiosphere, we have to equally be prepared for some kind of light signature that is a marker of an exo-civilization. So yeah, those louvers, of somebody, that would be a much simpler way of doing things. If you were trying to communicate your existence to another, to the rest of the universe, putting exactly that, doing something like, putting some kind of star shade in front of your planet, in front of your star to be able to, produce unusual light patterns, yeah, that would be a reasonable way of doing it. But of course, the always thing with SETI is, of any kind of SETI, is that it always ends up being this sort of, like the old honeymooners show. It's like, well, I know that you know that I know that you know that I know that you know. You're always setting up the idea that like the other species that you're looking for, or the species you're looking to, that each other's intentions. And that may be stretching it. I'm much more in favor of looking for techno signatures that are unintended, right? You didn't mean to send a signal to space, but yeah, you had to cover half your planet in solar panels because to power yourself, and that left an imprint. So that I'm more in favor of those kind of strategies of looking than thinking that somebody intentionally puts out a marker.
Now, one thing about that though is like with KIC 8462852, you could see that wasn't really anything intentional. If that was going to be some alien megastructures, it was something that they would have been doing. Right. And the only reason we saw it was because of the nature of Kepler. We saw that it was staring at the same spot in the sky for over months and months and months, and could see the dips, the light curve dips. Now, what equipment, because Kepler's basically finished, what equipment is coming online that's going to help to detect stuff like that? Do you think the LSST in particular is going to be where we can take a look?
It's an interesting idea.
Yeah, what's going to come of things like that basically take sky surveys every day and a half? Are we going to see more of these things like this on a bigger scale? Because we're looking at a much bigger area than what Kepler could see. Do you have expectations there?
Well, it's not, LSST was interesting because it's the time domain, but they still don't have, they're not going to be able to do the transit stuff. So they're, it's possible they could, you have to be a pretty big signal for LSST to be able to pick it out. Some kind of like hyperspace warfare or something. But, the James Webb Space Telescope and possibly there's also HabEx people are thinking of. There are missions that are planned that will be able to do transit spectroscopy at higher levels of refinement to be able to do the atmospheric characterization and such. So I think over the next, and then there's just these, outrageously large telescopes we're building even on Earth, the 30-meter class telescopes. It's remarkable to think of a telescope that is 30 meters in diameter,
unreal.
So, but those also are going to have the ability to really characterize atmospheres as well. So to me, that's the most exciting thing, the ability to really understand what is to be able to characterize the spectra, the light coming from planets, through transits, or even if you could do, some missions are focused on direct detection. But that's the thing that's going to be most exciting from my perspective.
Well, even just the raw science of it, of being able to study an exoplanet's atmosphere and compare it to what we have here is amazing. Especially considering when I first got into amateur astronomy in 1987 or whatever, we didn't even know planets existed.
I know.
And it's come so far over that amount of time. Now, there's other options with alien civilizations, and one of those would be like a von Neumann probe, where they could have stationed something in the solar system and just quietly watched, Arthur Clarke's monolith or something like that.
Right.
And it's always been suggested that might actually be a very efficient way of exploring the galaxy, is by creating self-replicating probes. Or is it? What do you think?
Well, I think that, you could take that question even further, which is, if a civilization reaches our point and manages to get through its climate change and last another 100,000 years, is it all become silicon anyway? Is the biological phase of civilization evolution relatively brief compared to its silicon phase? And, I find that a very intriguing possibility. I can see the logic of it. I'm not a big fan of the singularity. I think, the idea, I don't think we understand consciousness well enough to sort of say that, the idea that we're going to download ourselves into machines. But I certainly can imagine that we create intelligent machines that might outlive us. So, that's an interesting thing in itself. But there is a way that it does, as we're seeing already with solar system exploration. It's really expensive to send people. It's relatively cheap to send probes. So in many ways, a von Neumann probe, would make more sense in terms of exploring the universe. But you got to remember, the problem is that, if you're just having von Neumann probes go out and send signals back, you better be a pretty long-lived civilization, because it's going to take hundreds of years for them to get to get across space.
Right. And I mean, essentially, you probably would have to be a machine civilization to do such a thing. But you got to ask the question, if we say we did get a SETI signal and it was a machine on the other end, it was a machine civilization.
Yeah.
I mean, what does that change? Is that terrifying? Is that interesting? What, I think that would be one of the more interesting signals we could get if we could decode it. Now, in your book...
Right, if we could decode it.
Yeah, if we could decode it, which is big if.
Right. I love... Go ahead.
No, I'm just saying it's a huge if. That's sort of the one thing where there is no guarantee there, so...
Right. I loved the movie Arrival for that reason, because the film, and I guess it's based on a book. I have not read the book, but they send in a linguist and a physicist, and the physicist does the usual thing like, I'm going to show them pi, and then we're going to work out the mathematics, and that's how we'll communicate with each other, which has always been the standard since Carl Sagan line, and it just fails miserably. I just thought that was such a great, the hubris of physicists, which I am one, that, we'll just, we'll communicate with math. And the linguist is the one who's like, no. Language does not work that way. It's much more subtle than that. So, this question of whether or not we'd ever be able to, even communicate is an interesting question. But if it was machines, I think that would be even more interesting if it was machines, because, how'd you guys get that way? Do you have... What are your thoughts about being machines? I'm a great fan of science fiction, and there are lots of stories along these lines. What's really interesting with machines is just because you're intelligent doesn't mean you're conscious, right? And so Alastair Reynolds is one of my favorite writers. He did a whole series, I think it's called is it Neptune's Children? I can't remember. Poseidon's Children. A series about, about Earth and the first century ship which leaves Earth for the stars, and it encounters a machine intelligence. But the machine intelligence is not conscious. It's intelligent, but it doesn't have any self-awareness. And that distinction is a very interesting one for thinking about, how civilizations might evolve. And, if you're not conscious, what are you? What does it mean to be intelligent without consciousness?
Yeah, certainly. And that has to be asked in particular to machine civilizations, because it may not even need to be conscious.
Right.
Now, in your book, you spend a lot of time on something that I find particularly interesting, the Drake equation.
Mm-hmm.
Now, again, years ago, we didn't really have much to plug into that equation, but now we do, and you point that out in the book. What do we know from current science about the Drake equation? What can we infer?
Yeah, the interesting thing is that when Drake wrote down his equation, there were 7 terms. Each term is a different sub-problem in thinking about civilizations in the universe. And when Drake wrote it, there is basically only one of the 7 terms, could they even make a reasonable estimate at. And that was the number of stars in the galaxy, or another way of putting it is the birth rate of stars. And so there are of the 7 terms, you can group them. The first 3 are about astronomy. The second 3 are kind of about biology and evolution. And the last one is about sociology. It's about the longevity of civilization. And what's remarkable is, since Drake wrote down the Drake equation, we have now nailed all the astronomy terms. All the astronomy terms are not only do we have numbers for, we even have error bars. So that is a unbelievable advance. And from that, there is, if you ask the right question, you can actually say something about exocivilizations, right? And the thing about science is always finding the right question that the data can answer, right? It may not be the question you really want to have answered, but it's if you ask the right question to the data, you can get some kind of answer. So what Woody Sullivan and I, a collaborator of mine, did in 2016 is we wrote a paper where we modified the Drake equation and rearranged it to ask this question: how bad does the probability per habitable zone planet, if you take a random planet in the right place for life to form, how bad does the probability of forming a civilization on that have to be in order for us to be the only time it's ever happened in the entire history of the universe, right? That's a very specific kind of question, right? It doesn't tell us, whether there's anybody nearby. It just says, how bad does the probability have to be for us to be the only time it's ever happened? And that number turns out to be 1 in 10 billion trillion, right? So that's a pretty low number, right? 1 in 10 billion trillion is a very low number. And so what the conclusion we reached from, we got that from basically using the Kepler data. So that's an empirical number. That number is not theory. It's an actual it's a pretty simple result actually to derive. So what does that tell you? Well, what it tells you is that, we don't actually know what the probability is, right? All we did, we were able to set a limit. We were able to tell you, okay, if nature conspires to make that probability any lower than 1 in 10 billion trillion, yeah, then we're alone. But if nature, nature's evolutionary processes make it any bigger than 1 in 10 billion trillion, then it's happened before, right? And 1 in 10 billion trillion is so small that you don't have to work very hard to get nature to make it, to have nature have nature's probability, nature's actual process, to give you something greater than 1 in 10 billion trillion. So, for me, that result was kind of stunning because it said wow, unless nature is really biased against civilizations, then this has happened before. What is happening with us has happened before over cosmic space and time. So, that to me is what's so remarkable about what we've learned from the Drake equation.
All right, and on that note, we will take another break. We will be back soon to wrap up with Dr. Adam Frank, author of Light of the Stars, Alien Worlds, and the Fate of Earth.
Thanks for watching Event Horizon. If you like what you see, you can support us on Patreon via the link now on screen. And I promise not to let John spend the money on frivolous things like beans. Remember, next week we'll be giving away 5 of John's books, Supermind, to 5 lucky commenters. All you need to do is subscribe to Event Horizon and make a comment below.
And we're back with Adam Frank for our last segment of today's show, Event Horizon. Now, we've been talking about this, that the chances are still pretty good that there's, plenty of life out there. And personally, I can't imagine that very simple life wouldn't be extremely common, because we seem to see so many places in our own solar system where it could be, Europa, Enceladus, places like that, Mars even.
Right.
So it doesn't seem to be that. But if we continue to not see anything, and that we just see this great silence, at what point must we conclude that intelligent life is extremely rare?
Yeah, that's an interesting question. You could talk to the people who are looking for dark matter now and ask them, dark matter particles, because people, how long do you take negative results without saying like, oh, you know what? We haven't actually found, that what we're looking for actually doesn't exist, right? So, I think with extraterrestrial life, you'd have to look for quite a long time. I mean, I personally wouldn't be willing to make that conclusion unless it had been like literally hundreds of years that we've been looking. Because like I said, the parameter space is just so vast. The possibilities for, alternative explanations are just too vast. Maybe people don't want to be seen. Maybe people are using technologies we don't understand that we can't, that our detectors aren't tuned for. But, certainly after a couple of centuries of looking and still it was zero, then I think it would lead to some, and it would be kind of an existential crisis too. God, imagine if we were the only time it happened over cosmic history. That would be pretty, what would we make of ourselves in that case?
I think the most scary one for me is of the suggested great filters. I think the one that scares me most is this idea that it's very difficult to leap from prokaryotic to eukaryotic life, and that it took Earth life, I think, 1.8 billion years to do so. Right. And it just seems like if there's a great filter, it's probably something like that. But there's also that time factor that we talked about briefly earlier. There could be multiple civilizations in the Milky Way across its history, but they may not coincide at the same time. They may destroy themselves, or they may just last for a billion years and then go away, or go extinct, or go quiet in some way. So there's also the problem of just not existing at the same time as another civilization. Right. But even still, if you look at the vast multitude of galaxies present in the observable universe, surely there's more. So I don't know if we could ever say that we were actually alone, right? Just in the Milky Way.
That's exactly the problem, right? So that's really the problem. But the problem you're bringing up about overlap is really, really important, right? Because if every civilization lasts even for like a few thousand years, which would be pretty remarkable, if we still had imagine we had another 10,000 years ahead of us. Wow, what could humanity become in 10,000 years? But imagine that 10,000 years is the average lifetime, that is so short relative to cosmic timescales that, we could easily, right now, if every civilization lasts 10,000 years, it would be relatively easy to show that, in general, we're not going to find anybody in the galaxy, right? That the nearest one could be, quite far away. So, that overlap, it really, really depends on the timescale, the average lifetime of a civilization. Which is something we tried to calculate. That's one of the things we're actually relative, if climate is a great filter, and I think climate could be one filter. It doesn't have to be the great filter, but it'd be one filter. But, we actually, in the book, I talked about, we one of the projects we're working on is running calculations about the trajectories of civilizations and their planets, the co-evolution of civilizations and their planets. Because for young civilizations, right, there's only so many energy modalities you've got, right? There's, maybe you can burn stuff, fossil fuels or biomass, solar, heat, wind power, etc. And those ones you can kind of calculate what the relationship between using that energy and its effect on the planet are. So I think, that's one place we can actually try and model the progress of civilizations. Once you get to very advanced civilization, who knows what they have available, and it's really not possible anymore.
So if a civilization is symbiotic with its own planet, or planets if it colonizes its own star system, it doesn't really go any further because it's just too energy intensive to travel distances involved with interstellar travel. Eventually they go extinct anyway because, for example, our sun, the luminosity of the sun is increasing and will eventually cook us, and we just will not be able to continue on unless we have habitats or something that we've moved out, into a safer area. So does that mean that there are hard exits for civilizations, that they eventually something happens that they just can't get past unless they've, colonized a whole bunch of red dwarves that they're using to, survive for billions of years? So do you think that could be a solution to it? Is that just civilizations there's not much to do, they just await the extinction of their star, and that's it. Turn off the lights, and somebody turn off the lights, and that's it.
Fade into the, it's funny because people have talked about, there's been a bunch of papers, obviously highly speculative papers about how civilizations could maintain, their existence even into the, remarkably far-flung future when all the stars have burnt out and all the, so, I think it's hard to say that, again, these are, really interesting science fiction-y kind of questions. I'll tell you what I do think about is that if we got another 10,000, 100,000 years of evolution, who knows what we could become. I mean, sometimes, maybe, that sort of very science fiction idea that, literally we are able to climb, we stop being biological at all. And, we're able to climb into the laws of physics in some sense, right? Which is that sort of the interstellar. I mean, it's so hard to imagine another 100,000 years of our evolution, given the pace of change that we have now. So, I kind of throw my hands up and say, just let's see if we can get through the next few hundred years, right? Let's see if we can just make it through this, what I think is a very generic bottleneck of climate change. And then, the stars await.
So do you foresee an end of the Anthropocene in the sense that at some point, perhaps within the next 100 years or 200 years, just setting a singularity aside or anything like that, that we just simply become so technological in what we do? Perhaps we're still biological in some sense, but we move from the Anthropocene into some sort of technological age. Or have we already done that?
Yeah, we've already done that. And, one of the things I really emphasize in the book is that, Kardashev's Type 1 civilization is a massive, I call it planetary brutalism. It's a massive misunderstanding about how planets work, right? So, the Kardashev scale has this inherent kind of very macho scientific sort of, we will bring the planet to heal with our enormous energy harvesting capabilities, so it's the whole gleaming silver spaceship thing. But the whole lesson of the Anthropocene is like, no, planets have minds of their own, pal, and you can't just you can't bring a planet to heal. What you can bring it, though, is a plan. And that, planets are basically planets harvest cosmic scale energies, i.e. starlight. And, what the future, there's never going to be the end of the Anthropocene. We're entering an era where we are going to have to understand how to come into some kind of cooperative relationship with the biosphere. Because we have to recognize that we are the biosphere. We're part of the biosphere. We can't lift ourselves above it. If we settle Mars, it's not going to be human beings settling Mars. It's going to be Earth's biosphere settling Mars, using us as its proxy in some sense. So I think, that the recognition, the understanding of climate change, the real astrobiological meaning is that, biospheres are the central agent and actor, and the individual species that are evolved by the biosphere are secondary to it. And if we want any hope of making it long term, we have to, sort of place ourselves back into a biospheric context.
Interesting idea that, yes, it really is. If we terraform something that does represent Earth's biosphere colonizing another world more than it does ourselves. And on that note, we are out of time. Joining me today was Dr. Adam Frank. His new book, Light of the Stars, Alien Worlds and the Fate of Earth, is available at your favorite online book retailer or bookstore, and be sure to check it out. Thanks for being with us today, Dr. Frank. I really appreciate it. It was a great conversation.
Oh, it was a great conversation. Thank you so much.
Wondering what exocivilizations are like is a very open field, since we have yet to see an example other than ourselves. But by looking at the challenges we face as a civilization, we can speculate. Will they have changed their climate for good or worse? Will they have terraformed other worlds? Will they survive their infancy? This leads me to wonder if some civilizations don't survive their infancy. Would we still be able to detect them? One such concept to answer that is called Artefact Seti, where some physical evidence of a dead civilization might be found. After all, we have a number of spacecraft on their way out of our solar system, any of which could eventually run into someone in the vastness of deep space. But I also wonder about civilizations that might be on the cusp of going extinct. What would they do in their last days? Might they look to space for salvation out of necessity? What if the first message we ever detect and decode from an alien civilization is a plea for help? Next week, I'll be joined by Seth Shostak, a man who has literally made a bet involving cups of coffee that alien life will be detected sometime within the next 2 decades.
I'd like to make a bet, John, that it's a good idea to thank the people who have chosen to support us on Patreon.
For once, I agree with you, Anna.
You always agree with me. You're just not always aware of it.
What?
You're not always right, John.
Well, at least this time, we do agree. Many thanks to our patrons who made our Patreon launch a complete success. You can find a link below to our Patreon page where you can join them in supporting Event Horizon. Thank you, and see you next week.
Thank you, wonderful humans.